$2, 4 tin cans, that's it. That is the total material cost of a device that burns 3 to 4 times more efficiently than an open fire. It reaches temperatures above 1,000 degrees Fahrenheit. It runs on sticks from your yard. No propane, no fuel canisters, no supply chain. It was invented in America. It was deliberately made free. And its legal status in this country is, to put it politely, ambiguous. Meanwhile, the commercial camp stove sitting on a shelf at your outdoor retailer costs $30 to $300. And that's before you start buying propane canisters. Every single one of those canisters is a link in a supply chain that vanishes the moment you actually need emergency cooking capability. By the end of this video, you will know exactly how to build a rocket stove in 30 minutes. You will understand the combustion science that makes it outperform stoves costing 100 times more. And you will know the specific EPA regulation that put this device in a legal gray zone. To understand why this works, and why you've probably never heard of it, we need to start with the man who gave it away for free. Welcome to the channel. What we do here is simple. We find practical knowledge that works. Knowledge that exists outside commercial product lines and outside mainstream emergency guidance. The kind of information that has no marketing budget behind it because nobody profits from you knowing it. If that sounds like something worth staying current on, subscribe now. You'll understand why by the end of this video. In the early 1980s, a researcher named Dr. Larry Winiarski was working at the Provecho Research Center in Cottage Grove, Oregon. His problem was not abstract. Every year, millions of people in the developing world were dying from household air pollution, exposed cooking fires inside poorly ventilated homes. The smoke alone was killing people at a staggering scale. The World Health Organization puts that number at 3.2 million deaths annually. That is not a historical figure. That is the current annual toll. Winiarski's goal was engineering. Design a combustion device so efficient that it dramatically reduces smoke, burns a fraction of the fuel, and can be built from materials available anywhere on Earth. What he developed was the rocket stove, an L-shaped combustion chamber with an insulated vertical chimney. The design is elegant in its simplicity. Small diameter wood feeds horizontally into a short tunnel. The tunnel turns upward into an insulated vertical column. The insulation keeps the fire hot. The hot air rises. The rising air pulls fresh oxygen in through the fuel opening. The hotter it burns, the stronger the draft. The stronger the draft, the hotter it burns. It is a self-reinforcing cycle. And here is where Winiarski made a decision that tells you everything about his priorities. He refused to patent it, deliberately, openly. He released the design into the public domain because the entire point was saving lives, not selling products. The result was global deployment. Humanitarian organizations carried the rocket stove design across sub-Saharan Africa, into Southeast Asia, through Central America. Military units adopted it for expedient field cooking. The device has been built and used on 3 continents by people with no engineering background and almost no budget. It works. That is not debated by anyone who has tested one. So a device designed to save millions of lives was given away freely to the world. Now let's talk about what happens when you actually light one. What you're seeing today is the surface of our research on this topic. Inside the vault, we go deeper. Advanced rocket stove variations for different fuel types. Permanent build designs using fire brick and steel. Fuel preparation and storage guides for long-term readiness. The full regulatory breakdown with state-by-state enforcement analysis. No fluff, no filler. Just the information laid out so you can act on it. The link is in the description, but stay here. Because before you build anything, you need to understand why this device outperforms stoves that cost 100 times more. The combustion science is straightforward once you see it. A traditional open fire wastes most of its energy. Heat radiates in every direction. Smoke means unburned fuel, volatile gases that never reached ignition temperature. The fire starves for oxygen at the base while heat escapes from every side. It is thermally chaotic. The rocket stove solves all of this with geometry. The L-shaped chamber concentrates the combustion zone. Wood enters horizontally through a short feed tube. The burn happens at the elbow where the horizontal channel meets the vertical chimney. Now here is what matters. The vertical chimney is insulated. Vermiculite, perlite, even dry ash works. That insulation keeps the interior wall temperature high, extremely high. Published testing data from the Provecho Research Center shows combustion temperatures exceeding 1,000 degrees Fahrenheit inside that chimney. At those temperatures, the volatile gases that would normally escape as smoke ignite and burn. You are burning your smoke. That is why a properly functioning rocket stove produces almost no visible emissions. The efficiency numbers back this up. Provecho's testing documented a 3 to 4 times efficiency gain over an open fire. Fuel consumption drops to roughly 1/5. 1/5 the wood for the same cooking output. The thermal performance is competitive with commercial propane stoves. These are not estimates. These are published, reproducible test results from a research center that has been studying biomass combustion for over 4 decades. The World Health Organization has recognized this technology as a meaningful intervention against household air pollution deaths. This is not fringe science. This is tested, validated, deployed combustion engineering. A device that burns cleaner than most certified wood stoves, costs $2, and runs on sticks. So why isn't this in every emergency kit in America? The answer is one specific regulation. Open your browser. Search for 40 CFR Part 60, Subpart AAA. That is the section of the Code of Federal Regulations where the EPA regulates new residential wood heaters. Read the language carefully. It covers solid fuel-burning devices. That phrase is broad, intentionally broad. Any device that burns solid biomass fuel falls within its reach. Now here is what that regulatory text does not contain. There is no certification pathway for a homemade device. None. The certification process requires manufacturer testing, EPA-approved laboratory evaluation, and compliance documentation. It was designed for manufactured products sold commercially. The device you build yourself from 4 tin cans in your backyard does not fit inside that framework. It cannot be certified, not because it fails emission standards, not because it has been tested and found wanting. It cannot be certified because the process does not accommodate its existence. The enforcement reality varies by jurisdiction. In rural areas with no active air quality management district, nobody is checking what you cook on in your backyard. But in California, Oregon, Washington, and much of the Northeast, air quality districts enforce burn bans and solid fuel device regulations actively. During a burn ban, operating any uncertified solid fuel device can carry fines. Your rocket stove, the one that burns cleaner than the certified wood stove your neighbor bought for $800, is the uncertified device. Their stove has paperwork. Yours has performance. The regulation measures paperwork. Let that settle for a moment. A device that produces less smoke and fewer particulate emissions than most certified residential wood stoves is treated as less legal than those stoves. Compliance is measured by certification status, not by actual emissions performance. And it goes further. Look at FEMA's emergency preparedness guidance for cooking during extended power outages. You will find references to commercial camp stoves, propane, charcoal grills used outdoors. You will not find the rocket stove. A $2 device that eliminates fuel supply dependency entirely is absent from federal emergency cooking guidance. The commercial camp stove market runs from $30 to $300 per unit. And every one of those stoves requires ongoing propane canister purchases. That is a recurring revenue model. A rocket stove has no manufacturer, no marketing budget, no retail margin, no lobbyist. It cannot compete for attention against products with funded distribution channels. Now you understand the device, the science, and the regulation. Here's what you need to know before you build one. If you're still here, you're exactly the kind of person this channel exists for. This is the kind of information that matters when it matters. Hit subscribe. Share this with someone who needs to hear it, because this knowledge has no advertising budget. It spreads person to person, or it doesn't spread at all. Let me be direct about limitations. This is a live fire device. You must operate it on a non-combustible surface, concrete, bare dirt, gravel, not your wooden deck. Outdoor use is strongly recommended. If you use this indoors for any reason, carbon monoxide is a real and lethal risk. Ventilation is not optional. It is mandatory. The tin can build I am about to show you is not permanent. Metal degrades through oxidation and thermal fatigue. You will get dozens of uses from a well-built unit. You will not get years. Your fuel must be dry. Wet wood kills efficiency immediately. The draft stalls, smoke increases, performance drops to open fire levels. Dry, where small diameter sticks are what this device is designed to burn. One more thing, this is a cooking device. It is not a space heater. Rocket mass heaters exist for home heating applications, but they require significantly more materials, more knowledge, and more permanent construction. They also attract more regulatory attention. The more durable and permanent your build, the more legal exposure you potentially carry. With those realities understood, here is exactly how to build one. You need 4 cans. One number 10 institutional size can. That is the large can you see at restaurant supply stores or in commercial kitchens. Roughly 6 inches in diameter, 7 inches tall. Then 3 standard size cans. Soup cans, bean cans, approximately 4 inches in diameter. You need vermiculite or perlite insulation. Available at any garden center for a few dollars. And you need tin snips. That is your entire materials list. Total cost sits at approximately $2 if you already have tin snips. Remove the tops and bottoms from 2 of the standard cans. These become your chimney sections. Cut a hole in the side of one chimney can near the bottom. The hole should match the diameter of your 3rd standard can. The 3rd can keeps its bottom intact. Cut out only the top. This becomes your horizontal fuel magazine. It slides into the hole you just cut. You now have an L-shape, horizontal feed tube entering a vertical chimney. Place this L-shaped assembly inside the large number 10 can. Center it. The chimney should sit roughly level with the top of the outer can. Now pack the space between the inner assembly and the outer can wall with vermiculite or perlite. Pack it firmly. This is your insulation layer. It is what makes the entire device work. Without it, you have a smoky fire in a can. With it, you have a rocket stove. Your cooking surface is the top of the chimney. A small grate or 2 pieces of metal across the top hold your pot. Leave a gap for exhaust to escape around the pot edges. To operate, feed small diameter dry sticks horizontally into the fuel magazine. Light them at the interior end where the horizontal channel meets the vertical chimney. Within minutes, the draft establishes itself. You will hear it. A low roar. That sound is the self-reinforcing combustion cycle engaging. Feed sticks incrementally. Push them inward as they burn. Your heat control is the amount of fuel in the magazine. More sticks, more heat. Fewer sticks, lower simmer. This device boils water. It fries. It simmers. Any cooking task you perform on a standard stove, this handles. Total build time is approximately 30 minutes. Total cost is $2. It replaces a $100 camp stove and eliminates propane dependency entirely. You now know how to build something that most people in this country don't know exists. A combustion device invented in America by a researcher who cared more about saving lives than selling products, made free on purpose, proven across 3 continents and multiple decades of humanitarian deployment, validated by published testing data showing 3 to 4 times efficiency over open fire, recognized by the World Health Organization. Capable of cooking any meal on fuel you can gather from your yard, built in 30 minutes for $2 from 4 tin cans, and sitting in a regulatory gray zone because the compliance system measures certification paperwork, not actual emissions performance. The regulation exists. Now so does your knowledge. You're not dependent on any supply chain for cooking, not on propane, not on natural gas, not on electricity. Sticks and a principle of combustion that no one can patent, no one can recall, and no one can take off a shelf. Share this video with someone who should know this. The next build in the vault goes further. We will see you there.